Oh, hi, welcome to the Calculus 3 lecture series. We are in the unit of vector calculus. So this is the lecture number 6. We're talking about the green theory, and this is the second video about this lectures here. Okay, so let's go to our lecture notes and start to talk about what we're going to cover in this videos here. Okay, so from our previous videos, we start to introduce the green series, right? So basically we say, if you have a simple closed curves here, so this is the C, and then if you want to integrating, right? So this curve of, you have a field f of x, y in the curves here. So the green theory basically tell you, say, hey, you can change that to something we are familiar with, right? So they say, okay, how about if this is the area under it, right? So basically they say here, say, hey, you can change to the integration notation we are familiar with. So it will be like rho q over rho x minus rho p over rho y, and you're integrating over this area, and so this is what we change to, right? So it's rho q over, then you can like take a look, you want to integrate. So this one's here, you can say it's dy dx, right? Then you find the appropriate boundaries for the, those integration limits here. So now we are going to continue from this thinking here. So we said, like in the Calc 2, right? So in the Calc 2 here, okay, so if you have close areas here, so like for example, you have this ones here, this is C, and you have these areas inside here, right? Okay, so this is my area D here. So, like in the Calc 2, we say, how do I find this area? So we say, hey, we can use the double integrations, right? So you say it's 1 and dA here, right? So it's over this region. That's what we did in the, the Calc 2. Of course, like in here, we say, the dA, you can change it to the dx dy or dy dx, and then give them the appropriate the limits here. So this is what we did in the Calc 2. So now how, now can we use the green series to do this? Okay, will be that easier, right? Okay, so let's take a look. Can we use the green series here? So I know that this ones here, the green series change to us is to say, hey, this ones here, I can, just like we say here, right? So it's rho q, rho x minus rho p, rho y, the dAs, right, over these here. So if I want to use the green theory to do this, look here, right? So what I have here, that means if I can find some type of the functions, rho q over rho x minus rho p over rho y is equal to 1, right? If I can find a rho q rho, some type of, if I can find some qxy and the pxy, and which will give you this results here, then I can use the green series to find it, okay? So how do I do that? So there are many choices of x, y. So this is what is the next slide is about here. Okay, so that's what we said here, right? So one way to do that's what is our calculus one way. So it's 1dA because the green series, right? So that means if you can find rho q rho x, rho p rho y equal to 1, then I can use the green series to do that. So this table just give us like 3 very, very commonly used pxy and qxy's here. Okay, so for example, pxy is 0, qxy is x, or it's negative y is 0, because all this, right? So when you combine them into these integrations, it will be equal to you know, the rho q over rho x minus rho q over rho y is equal to 1 here. All right. Okay. So now let's take a look at this one here. And we're going to see several examples, couple examples here. Okay. So now let's take a look. This is the first ones here is how do I use the line integral to find the area? Okay. So we all know here, we learn that in the, you know, because of the radius here, this is 2 3s, right? So the radius is 1. So what is the area for these circles here? So the area is what? Area is pi r squared. So it's pi. All right. So this is what we learn in the geometry. Maybe in your elementary school, you learn that. Okay. So now let's take a look. How do I use the green series to find the, you know, how do I use the green series to find it? Okay, so the first here, I need to parameterize it, and so I can use the green series. Okay, so now because this is circles, right? So with radius 1, so typical we say is x equal to r theta. So now because we also have a center, so the parametric is I can say x equal to what? 2 plus sine theta. Correct? 2 plus cosine theta, I'm sorry, here. So it's a 2 plus cosine theta here, right? So that's 2 plus cosine theta. And now let's see here. So here, right? So here, okay, so let me erase this. Let me put the x like the typical we did is x equal to the 2 plus cosine theta. And the y is equal to 3 plus sine theta. All right. And then I know my theta is from 0 to 2 pi here. Then the same way I can say dx equal to the negative sine theta, d theta, right? Then the dy here is equal to cosine theta, d theta here. Okay, and now in the green series here. Okay, so like we said, we can have these choices here, right? So now let's try to use this one. Okay, so now I'm going to try to use the two of them. You will see they will get the same answers here, right? So I'm going to use this one here, right? Okay, so now I will say here, so I say I can use the green series, right? So this is 1/2. And I'm integrating along these circles here. So remember, I want to use the third one. So it's x dy minus y dx here, right? So I want to use the green series for that. So I choose this one here, right? So this one will give you is 1/2, right? So now the delta, the theta, the x and the y, you can parameterize. So x equal to 2 plus cosine theta, right? So you say it's 2 plus cosine theta. And what is the dy here? Dy is cosine theta, right? Then minus y, what is y here? Y is 3 plus sine theta, right? Then dx is what? Is negative sine theta. See here, now you change everything to what? It's d theta here. So theta from the 0 to what? 2 pi here, right? So if I simplify that a little bit, so then this one here is 0 to 2 pi, and this will give you 2 cosine theta plus 3 sine theta plus 1 d theta, right? Okay, now you do integrations here. This is 1/2 pi. Then I have this 2 sine theta minus 3 cosine theta plus theta from 0 to pi. Well, give us the area of the pi, like 1 we always know. All right, so this is the one, like I said, you can have choices here, right? So now I'm going to do another one. So how about if I accidentally I want to choose this one? Will it give me the same answer? Well, let's take a look then, right? Okay, so now we still do the same ways here, right? So I say x equal to the 2 plus cosine theta, y equal to the 3 plus sine theta. So from above, I do the same thing, dx equal to the negative sine theta d theta. Then dy is equal to the cosine theta d theta, right? Okay, so now I say I'm going to use this one, x dx, all right? So I'm still changing everything to 0 to 2 pi, so it's theta. So what is x is 2 plus cosine theta times dx, the 2 plus so this is the x dx. Did I copy the, so I'm sorry, it's x dy. So this is x dy. I wonder. Okay, so this is x dy here. So we have this is x dy. Okay, so I copy wrong. So this is x dy, right? So this is x dy. So dy is cosine theta, right? So I have a cosine theta d theta. Well, so since this one is simplifies a little bit, so this is 2 pi. Now I have a 2 cosine theta plus cosine square theta d theta here, right? So though I know the integration of 2 cosine theta, then the cosine square theta, I can use the double angle formula, right? So I know the cosine 2 theta is equal to 2 cosine square theta minus 1. So I know the cosine square theta is just be the 2, 1 plus cosine 2 theta, right? Okay, so now you just integrated, so this is 0, 2 pi, then this is 2 cosine theta plus 2, 1 plus cosine 2 theta d theta. Okay, so you're integrating this ones here. So this will be the 2 sine theta for 0 to 2 pi, right? Okay, so then this ones here, you can simplify that. That will be the 1/2. Then you will have here sine 2 theta over 2. Then this is 0 to 2 pi. Then plus theta 0 to 2 pi here. Okay, so like this here, this one, this one will be 0. Then this will be 0, so it's 2 pi half. What do we have here? We have a pi here, right? So it will give you the same answers here. That's pretty cool, right? Okay, so now let's take a look at our last examples about these ones here. So these ones here, we said let D is this regions, right? C1 is 1 minus x squared, and the line is 1 minus x. Okay, so the first thing is here, if I want to use the calculus 2 methods here. So how do I use the calculus 2 methods here, right? So for the calculus 2 methods, so what do we did here? So we say, hey, I can integrating, right? So I'm integrating x's here, right? So this area is what is this curve minus this curve, right? Because we know integrating is find the area. So this area will be equal to 1 minus x squared minus the 1, under these lines, right? Minus 1 minus x, you integrate to what? To the dx, right? So it's 0, 1. Okay, so then this one's here, that will just be the 0, 1. And then you have a negative x squared plus x dx. So the answer is 1 over 6. So this methods here, so this is the Calc 2 methods, right? So that's pretty easy here. Okay, So now let's take a look. How do I use the green methods here, right? So green series here. Okay, so first things I need to parameterize it, right? So C1 is this one, see here, right? So y equal to the 1 minus x squared. The same thing because my x start with 1, right? So for the C1, see here, I say x equal to the 1 minus t. Because it started 1, so when t equal to 0 is 1, right? Then y is equal to the 1 minus x squared, so it's 1 minus t squared. So far, so good, right? So the t is from the 0 to 1. All right. So now in here, now the same things here. Let's take a look here. Okay, so now let's take a look for the C2s here. So these lines here, how do we parameterize this one? So line is 1 minus x, right? So I can just let x equal to t. Then y will be 1 minus t, see here, right? So t is still from 0 to 1, see here. Okay, so from the, so for the, instead of, so the curve I'm going to use this one. So again, so it looks like a simpler. Okay, so for the first curve here, I have, so here for the C1, all right, so I have to have x dy. Okay, so now I'm just, the x is 1 minus t, then the dy, right? So dy is here, right? So dy, so is you take the derivative of the here, so this will be, so dy will just be 2 to 1 minus t, have a negative, right? So it's a chain rule, so it's a 2 minus 2t, so it's a 2 minus 2t, then it's from 0 to 1. Correct? Then it's dt. So you simplify this and you can integrate. This one will be from 0 to 1. This is 2. This is 1 minus t to the square dt. So you will have what here? You will have 2/3. Okay? Okay, so now for the C2s here. So for the C2s here, I'm still using these ones here. So C2, the x dy. So the same things here. So this is from 0 to 1. And then the x is t, dy. So this one's here, dy is what? It's negative dt, right? So it's negative 1 now times dt. All right, so this one's here is a little 0, 1. So it's a negative t dt. So what I have here, I have a negative 1/2. Okay, so now the whole integrations here for the x dy will just be equal to, you add these two, right? You add these two paths here, 2/3 and the negative 1/2. So what is here? So it's a 2/3 negative 1/2. What is here? 1/6 here. All right. So as you can see, they have the same answer. Of course, for this problems here, I think the calculus 2 methods is a little easier, but this is just a good example, try to show you how to use the green series here. All right. And it's the green series, not bad. And the integration is pretty simple as well. Okay. All right, that's it. That's for this section, the green series. I hope with 2 videos, you have a pretty good understanding about what is the green series about. Okay, and so that's it. And so looking forward to talk to you in our next topics here. Okay, bye.